Alright, let's take a look at the last example in this section. Example 5. At another performance, the heights above the seesaw versus time for the performers during the stunt are approximated by the parabola as shown. So what we have here is we've got some circus performers. They're jumping off a seesaw, landing on another seesaw. Right, we're going to assume that a second performer starts 1 second after the first performer. Right, so we've got one getting launched here, a second later, another guy's getting launched here, and they're going to switch positions. Their paths are shown on the coordinate grid. So the first performer gets launched, woo, the second performer gets launched. You notice they're going to cross paths at some point. Right? And the question asks us, A, to determine the system of equations that model the performer's height during the stunt. B, solve the system graphically using technology. And C, to interpret your solution with respect to this situation. Alright, so to determine the system of equations that model the performer's height during the stunt, we're going to have to figure out the equations of these two parabolas. Alright, we'll do these separately. We'll do performer 1 and then performer 2. Alright, one of the most standard ways to figure out the equation of a parabola is to use the graphing form of the equation. Y is equal to A times x minus p squared plus q, where p and q are the vertex of the parabola, x's and y's are any other points on the parabola, and A tells us the direction it opens and the width of the parabola. Looking at this graph, we can see that the vertex occurs right here with an x-coordinate of 1.75 and a y-coordinate of 4.5. So we have A times x minus, right, the first coordinate of the vertex is 0.75, and the second coordinate of the vertex is 4.5. To figure out the value of A to use for this equation, we need to use some other point that is on the graph. That other point is right here, 0 and 0, and so those become our y and x values. Alright, solving this equation for A, 0.5625 plus 4.5, so we get minus 4.5 is equal to 0.5625A. Dividing both sides by 0.5625, we get A is equal to -8. So the equation of our first parabola is y is equal to -8 times x minus 0.75 squared plus 4.5. We're going to go through this same process for our second performer. I'm not going to detail it quite as much. So again, we start with the graphing. We start with the graphing form of a parabola. We put in our vertex. In this case, our vertex is 1.75 and 4.5. We pick another point that is on the graph. And this time we're going to pick the point 1 and 0. Oops. Alright, and now we're going to solve for A. And you see, we end up with very much the same equation as we had before. So we get 0.5625a plus 4.5, negative 4.5 is equal to 0.5625a, which again gives me a equals negative 8. So the equation of our second performer is y equals negative 8 times x minus 1.75 squared plus 4.5. Those are our two equations for our two performers. Alright, again we're going to use the GeoGebra to figure out the coordinates of our solution. And alright, let's launch GeoGebra, and we're going to make our window full screen, center our coordinate axes, and turn the grid on. Alright, now we'll put in the equation of our first parabola, the one that had a 0 at 0, and should be coming up here any second now. There it is. Alright, so that's our first performer jumping, and now we have our second performer, the equation for our second performer coming up. And once we have that come up, we'll use the intersect command to figure out where those two parabolas cross. Right now we're entering the intersect command, and you're going to see that the point of intersection between those two parabolas is at 1.25 and 2.5. So we found that the curves intersect at 1.25 and 2.5. And then finally, interpret your solution with respect to this situation. Our solution means both performers. So our solution means that both performers have the same height at the same time. Right? This means they are right beside each other. Alright, so hopefully they're not right in line with each other, because if they're right in line with each other, they'll hit each other. But probably they'll be offset just a little bit so that they just pass right beside each other. Alright, so in support of solving systems of equations graphically with the use of technology, we've got an assignment on pages 435 to 439, doing numbers 1 to 3, 4 to 5, the odd parts, 6, 7, 9, 11, 14, and 20.